Hey everybody, this is Larry. This is day 16 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm. Today is a happy sports day for Larry. The Yankees won, and I ran 10 miles. Very struggled today, actually, on the running, but you know, you're gonna have those days, but if you're able to complete them, you know, it's okay. Just grind them out. And some days they'll be easy. So, you know, you don't complain and you just accept the fact that, you know, the easy days are fun. And then hope everything goes good. But yeah. All right, let's take a look at today's farm then. 1405, longest happy string. I need to get some more sleep, that's all. All right, let's go. A string S is happy if it satisfies the following conditions. It contains A, B, and C. S does not contain AAA or BBB or CCC. A contains at most A occurrences of the letter A. S contained most at most B or whatever. Okay, whatever. That's hard to say. Given three integers A, B, and C, return the longest possible happy string. If there are multiple happy strings, return any of them, and there's no substring, return the. Okay, I mean, I think this is there are harder versions of this. But it is a bit tricky in general, right? So if they're all the same, then you know, you're just going to be ABC, 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 and you're good, right? So the way that I think about these problems, and this is I consider ad hoc, but maybe you could say something else. But for now, anyway. But I'm just trying to make an observation on these problems. And like I said, yeah. So, but that's, you know, this is going to be the case. And then the question is then, okay, well, the constraints are actually very small, so you don't have to solve it analytically. You could, if you're able to figure out some sort of greedy relationship that will always work, then you can construct something that you can work on, right? And oh, I see. And it seems like you don't have to use all of them. It's just any possible of them. There'll always be a string, so I'm just trying to make sense of why there's no empty string unless like they're all zeros, obviously, which is not one of the input. So I don't know. Like even if you have like two A's, you could write AA is a happy string, right? So it's a little weird. But I think the way that we can construct this is try to think about. I think one thing that I am trying to think is whether there's a wrong way to construct it, right? Meaning that can you make a move like for greedy, almost like a proof by contradiction, or at least like a dot by contradiction. Maybe it's not a proof of like, okay, if I made this decision, this choice, it actually messes me up for later. So that's not good. So that's what I'm trying to think whether there's a case. But I think there is a way where, okay, well, if you have 7 A's and 1 B, then you want to take the A's, right? And you only get 2 of them, and then you break it down with either B or C. And I guess in a greedy sense, you want to take the max of B and C. And then now you have a sub problem of. I think the other thing is that, and I was going to say this, but you could use dynamic programming, even though it's not great. N cube will be fine. But you also don't have to prove, right? But n cube will be fine because each choice you could take 1A, you could take 2A, you could take, and that's it, right? And then 1B, 2B, 1C, 2C. So you could do it with dynamic programming, using how many A's, B's, and C's you have left, and maybe the last choice. But But I'm trying to think about how to structure it greedy quite precisely, right? And I think the only thing that I would want to avoid is something like if you Is that even true? Yeah, I think so. Because basically the idea is that, okay, you always want to avoid 2 consecutive like 2s in a row. Like, this is probably not optimal. The only reason why this is not optimal is because you can always convert this to an alternating one, right? And why this is better is because then now you're able to kind of squeeze things more in later, right? I think the tricky thing is that when you have 3 letters, right? Because if you have 2 letters like A and B, then you can do what I did and kind of squeeze things in a forceful way. But if you have another one, then you can't just be like ABC, ABC, and then like squeeze in A's. I mean, you can, but that might not be optimal, right? Because, for example, you can squeeze in even more A's here, and maybe this could be a B, for example, right? Why would it necessarily, you know? So that's just a little bit awkward. Trying to think for the possibilities. But I think I would be okay with, yeah, because then now, so okay, I mean there's this general thing, right, where, okay, let's say you have 2 characters, right, only A and B, then if you have 2 A's and 1 B, then this is good, right? So you could kind of take, and I mean like multiples, right? Meaning if you have 10 A's and 5 B, this is good. But if you have 11 A's and 5 B's, then this constrains down to 10 A and 5 B, right? And then now but now if you have add another character, so basically now your most popular character will be the thing, and then everything else is just a delimiter, right? Right, because if you have, say, 20A, 5B, 5C, this is still good because the most common is A, and then you can use these as delimiters in between, or maybe I'm off by 1, but either way, that's the idea, right? And then once you get it to a point where A is equal to B or equal to C or whatever, and they're all the same length, then you just do one at a time. So I think that sounds reasonable to me. Just take the 2. Yeah, right, so okay. So there, maybe I'm doing by case analysis then, right? So here, and it's a little bit tricky because we have A, B, and C, but right, because you have to actually return the output, not just a string. Though I guess that would have been very easy actually, or like very quick. Because basically, I'm trying to think whether there's a case like for example, if, or like, I know that this works, but I have to try to figure out what the exactness of it is. Like we have 12A, I don't know, 7B, 7C's, right? In that case, would you just do 2A, 2, and then like, and then just BC afterwards? I guess so, right? And in this case, I guess it's similar to the problems we had before with heaps, right? So okay, so let's do it that way then, right? Hey, this is why this is confusing, because the variable name, right? And actually, we want the max heap, right? We want the take, and we don't even need a heap because it's 3 numbers, right? So we just kind of we could use insort or something, right? And then now, so h.sort, right? Answer, and then how do we want to write it? Like, what is the ending condition? Well, one of them is if they're all threes are zeros, but that's not the only ending condition, right? So, well, now that we sort them, then man, I don't know why my brain is not working today. Sorry, friends. Honestly. Right, so maybe just let me do a while true loop, and then we'll more complicate it later, right? So then, okay, so then now, yeah, now we look at the max element, which is the last one. We look at the count. So that if this is so awkward. Or maybe I'm just being awkward, honestly. So I'm still try to prove that this is like the 2-1 thing is fine. Right. And I guess we can do case analysis, but it's a little bit awkward. Right. Okay, I think it forces the thing, so I think that's okay, I think. Okay, so we can just sorry friends at home. Today I'm just struggling a little bit. Maybe I needed my sleep and do it in the morning or something. But I don't know. Okay, so you take the biggest number, right? And then one of the not biggest number, and in that way you only decrement by 1. But right, so if this is greater than the second most character, I'm just trying to think the order of logic of if they're all equal, then like how do you make sure that it doesn't get repeated by accident? And then I guess that one doesn't matter after that. But yeah, okay. I think I see it maybe. No, I mean it could. like, because if they're all the same, then maybe do AB, and then next the C is going to be higher, then you do C, and then maybe A for sorting reason, and then after that it's going to be B, C, and then AB. Okay, fine. I think that sorts well. Okay. So yeah, so if this is the case, then we take right, and then oops. Nope, but yeah, and then now actually what I want is not tuples, so that we can manipulate these more directly. And the reason why we can do this, sorry that I'm taking so long, because I'm still thinking it through for whatever reason. But the reason why this works is because of, in a way, I have to double check that this is greater than 2 actually. Or greater than right, something like that. Yeah, I'm struggling a lot with a lot of these cases, but yeah, the reason why this works, I believe, is because of intermediate value theorem, right? Because H2 will always be, even with this, at most they'll be equal, right? Because this is greater than. So then this should be always be good. Oops. Though there is a sloppy thing, right, where if I have BA or B is equal to 2, A is equal to, well, let's say 3 and 2, then now I go BA, it goes 1, 1, and then we sort, and oh, that should be fine because we sort and they're the same, and because they're the same, we'll only go AB. Okay, I think that's fine then. But then we have to sort again. And maybe we just sort here. And keep in mind that when you sort 3 numbers, I'm being a little bit lazy. Otherwise, yeah. Is equal to H1 of 0. And of course, this is at least 1 item. Then we can just do the same thing, but only once, right? And then at the very end, then we break, because that means that there's no numbers left. Because if well, there is 1 number left, but yeah, actually we could break it and we can just check that. Yeah. Why is the, am I, oh, no. Am I missing a parent or something? The auto tab thing is taking me here for some reason. That's not even reasonable. Huh. What is going on? Why would they get... This is so weird. It's because I'm missing this thing here. Okay. Okay. In any case, yeah, so we saw it, right? And then now if, well, H2 of 0 is greater than 1, and if answer of -1 is not equal to this, the last number or the last digit, or the second to last digit is not equal to this one. So, because if either of those are not equal to, then that's good. Of course, you have to do bound to make sure that we have enough length. I can't even keep my eyes open. Sorry, friends. Someone like this. I need better sleep. Let's be more precise. Alright. Let's play around with it. I don't know. I'm not super confident about this yet, but it's a little bit awkward, and I know that I didn't do that good of a job explaining it, honestly, but okay, well, those are kind of edge cases that I was worried about. CAB, ABC, ACB. That's a very awkward one, actually. Why would it do that? We sort. Oh, what? No. Oh. Yeah, okay. Because I forget that we do the last character first of CB, and then A, and then. Two. And then it does A and then C. Okay, that's fine. Oh no, wait, CB and then AA? That doesn't make sense though. Well, I guess this is... No, this should be true. Wait, am I... Okay, yeah, that is what I was thinking of. C... Oh, no, it does the 2 and then it does this thing. So it does the 2A and then a C. Okay, I get it. Alright, I'm honestly not super confident about it, but I'm just a little bit YOLOing. Oh, okay. I thought this would... Oh, I check for these, but... okay, well... All length of answer is equal to 0, because then now that matches it. Okay. Why did I not... I don't know. Some days, even when I'm testing, I forget to test certain things. Okay, so it adds 1. I mean, this is the case, but I can't get the wrong, the different ones. Actually, I guess this is just like less than or equal to 1 because in that case, then it doesn't matter. Okay. Alright, so actually I was pretty close, honestly. I wouldn't be surprised if I tried to do this with dynamic programming 4.5 years ago, and I did do it that way. That's why, or 4 years ago. Not, yeah, 4.5, I guess. Well, almost 5 years. But, and we did talk about this possibility, and I guess I did do it in Python. It was timed out. But yeah, with greedy, it's fine. Sorry, friends. I'm like really... I should have done this in the morning instead. It's my fault. I don't think this is a good video, but if you're watching, thanks for watching. Thanks for being supportive. I'm gonna go to bed. Thanks for watching. Stay good. Stay healthy to good mental health. Hope this was good for you. I mean, probably not. But the idea is, let me try to summarize it at least. The idea is trying to just do it greedy, and I think the observation is that you could do the 2-1 thing because of the intermediate value field, meaning that you can pass it. So this will always give you, the second most common will always be, after this, at worst they'll be equal. And if they're equal, then, yeah. Then you just do one at a time and it'll always be good as well. And then we just have to kind of do this thing a little bit carefully. We can sort a lot, but yeah. Keeping in mind that so there are only 300, A plus B plus C is only 300, right? So that means that this loop will be at most 300 times, kind of, because we always subtract by 2. So this loop will only happen 150 times, right? And then the sorting is just 3 numbers, so 3 times 150 or whatever. So, not a big deal. That's why this is fast enough by a lot even, right? That is all I have for this one. It's a little bit yucky. I don't know. Use a greedy approach. Okay, fine. That's all I have for today. Let me know what you think. Thanks for watching. I'm going to try to go to sleep a little bit earlier so that I can do tomorrow's video a little bit earlier. Thanks for watching. Sports are tough. Stay good, stay healthy to get my mental health. Go Yankees, go Liberty, and go Mets. I'll see y'all later and take care. Bye-bye.